being that both of these are numbers, we will be able to evaluate or solve for the answer. So in this case, we'll have 4 times 4 times 4, 4 cubed, times 5 squared. And that is going to give us our answer. So 4 cubed, so we're thinking 4 times 4 is 16. 16 times 4 equals 64. All right, and then we are going to multiply by 5 squared, which gives us 25. Now our answer is going to be 64 times 25. So I'm going to get out my calculator so I know what I'm going to get. 64 times 25 is going to give me 1,600 for my final answer. These were my bases. These were my repeated numbers, the 4 and the 5, and then this is how many of them they were. Let's try again with our next one. How many different bases or repeated numbers do you see? I see an M and I see an N. So first I am going to write down my M, and then I also see an N. So I'm going to count 1, 2, 3, 4 M's, put my little exponent up top, and then I have 1 and 2 N's. So this is going to end up being my final answer for this problem because I do not know what the value of the variables M and N are. If I was given values, remember a variable can be any value, I can plug in and determine the answer. But for this part of the slides, we are going to leave the answer as this. For our next one, let's evaluate. Evaluate again, meaning solved. We have 7 to the 5th power. This means that 7 is our base and 5 is our exponent, which means we have 7 being multiplied 5 times to itself. Remember, it's not 7 times 5, because that would give us 35. It is 7 times 7 times 7 times 7 times 7. So we're going to take our calculators again, and we're going to type it in. But there is no value to a 5th power. We do not have that ability on our calculators. So there's going to be a different way that we're going to use it. You might see the notation or it being written as 7 caret, with this like kind of triangle, 5. This means that it's going to be, the base is going to be 7, and we're going to take it up to the 5th power. This can be seen on our calculators, I believe, right above the x squared button on most calculators. So now that we have that knowledge, we are going to type in 7, our caret, 5, and hit enter to get our answer. Our final answer for this exponent value or power value is going to be 16,807 is going to be our answer for that one. All right, let's do another example. Now, what is the value that is being taken to the 4th power? The base is going to be the entire number that is in the parentheses. So if I were to expand this and write this out, it'll be negative 2/3 times negative 2/3 times negative 2/3 times a negative 2/3. Okay, so make my dots a little bit bigger here. Remember, we don't want to use x's anymore. X's can stand for variables now. Makes it a little bit complicated. So when we do this, we can type this into our calculator using the -2/3. Remember, you have to use the negative button, not the minus button on your calculator. And then hit that caret button and then 4 to get our answer. But one thing I want you to think about, because sometimes calculators miss this, is what is it going to be? Is it going to be a negative or is it going to be a positive? Well, let's look. We have a negative times a negative, which gives us a positive. Now we have that positive times a negative, which then a positive times a negative gives us a negative. And then the negative times another negative will be a positive. So we know that our answer is going to end up being a positive number. So sometimes when our calculators are working so hard, they might not realize that there's so many negatives and it might keep the negative. So anytime you see a negative value taken to an even exponent, it's going to be positive. If it is a negative base number taken to an odd exponent, it will end up being negative. In this case, we can type it into our calculators and we'll get a decimal. So we have period 19753 and so on. But we also can change that into a fraction, which would be 16/81, which, if we think about it, we have our 2 times 2 is 4, times 2 is 8, times 2 gives us 16. Again, if we do, which is that top number, 3 times 3 is 9, times 3 is 27, and then 27 times 3 will give us our answer of 81. So you can do this both with the calculator and without the calculator. So now let's throw some variables in there. So when we work with variables, we need to evaluate the answer. We're going to take the numbers that they equal, so A equals 2 in this sense, and B equals 3 in this one. We are going to take them and essentially put them right in for these numbers. So what I like to do is put them in parentheses. So I'm going to do a parentheses squared, that's my A parentheses, plus open parentheses, close parentheses, and I'm going to put my B value in there. So this is important to put the parentheses because whatever happens maybe outside of these parentheses, it's this value inside it that has to be squared before you do anything outside of it. All right, so we have our 2 being put in for our A. So let's put our 2 in there and a 3 being put in for our B. We have 2 squared, which gives us 4, plus 3, which then will give us 7 for our final answer. Let's try another example with this. So if we want to evaluate x cubed plus y for when x equals -2, and oops, let's change that to a y because I wrote x twice. So that's a y equals 3. Let's see what this equals. So again, I'm going to open up my parentheses, have my exponent, plus my other value, open up my parentheses, leave a space, other parentheses. So let's enter in -2 for x. So we're going to do -2. And then we are going to enter in 3 for y. And we are going to start with that so we really see what these numbers will end up being.